writing and reading files. In this lesson, I would like to show you how to read a file and write to a file. It's also called I/O, input-output. In Java and also in many other languages, it's a whole framework. They sometimes have whole frameworks for that. It can be complicated and it can be simple. In this lesson, I want to show you two simple examples. There can be more complex stuff like copying files, manipulating images, etc., etc. When you get to the level when you need to do that stuff, you will be able to research it for yourself. Also in this course, you will see more examples of how to manipulate files. But in this lesson, I just want to show you the bare basics, so you can have a feel of how it's done. So what we have here is, in lesson 25, we have a files project and a foobar text. It has a very important message inside of it. It says blah blah. That's the content of foobar. To create a folder using Eclipse, you simply right-click the project, new folder, and here in the folder name you write the folder name and click finish. To add a text file, you right-click the folder you want to add the file to, and then you choose file and write the file name with the ending like something.txt. You can also do this from the file system by right-clicking properties and then going to the directory by clicking this here, where the location is. There's a button. It will open this folder. You can also copy the path, but it's better to do it through Eclipse. Actually, in our example, it doesn't matter. Let us begin coding. So first thing, I will write a comment, read file. That's so we'll know what the code under it does. So we'll start by writing the relative address of this folder. So when the program runs, its relative position will be here. So we will put it in a string, the relative address. We'll call it file name. And we'll write files / foobar.txt. That's the relative path to that file. The absolute path is C users / workspace / this project name / files. A very, very long path. That's why it's called the absolute path, because it's the path pointing directly to this file. We can use both, but I chose to show you the relative. Again, the relative, it's relative to this folder. The actual project is a folder, actually. So this will point to our file here inside our project, if you can see where my cursor is clicking. So after that, we will need to create an object to call this path and hold it. We will use... Actually, let's print it. Let's print the object. s.o. The object name is path. Paths, and the method we will use is get file name. In the get method argument, we will just pass our file name, and this will print this the way the system sees it. So here we have the absolute path. They use the different slash pointing in the other direction. That's probably how my system uses it. So we will use passes to point to this file, and we will need another string to hold our file content. We will call it S, and inside of it we'll create a new string object, not a variable, an object. This is how you declare a string object, like any other object. And inside of it, also notice it added an import to NIO file passes. So inside strings we will call another object related to the IO framework. It's called files, and we will use a method called read all bytes. This will read all the byte data in our file, and its path is this path, the absolute path. We don't pass the actual string, as the system reads it in a different way, so we will just pass this using passes and get. That way it will get the path using the path we specified, and then files using read all bytes will read it. So basically you create a string to hold the file name, and then you create a string to hold the file contents, string object. You call the files object, and then you call read all bytes methods, and inside of it you put passes and you call the string path, so it will convert it to whatever it needs to call the file. And as you can see, we have an error here. If you remember, in the last lesson we talked about exceptions, and I mentioned that calling files and manipulating files can cause exceptions. So here they force us to surround this with an exception. I can start writing catch, try, exception, whatever, or I can just hover it in Eclipse. It's an Eclipse feature, and then it gives me two quick fixes. We will choose surround with try catch. So it created a try catch for me exception, and it also prints the exception if an exception will happen, like if it didn't find the file, or if there was a problem or whatever. Let's put an end try so we'll know where it ends. And the last thing we want to do is output S, so we can output the contents of the folder. So again, you have the file path. We printed it here, and then we called this path using files.readAllBytes, and we put it inside a string object. The string object will convert the bytes to a string, and we can simply output it like any other string. Let's play it. Blah blah. Yep, that's the file content. Let's add 2. Let's save it. Let's run it again. Still works. Blah blah 2. It gets the content of the file even after we update it. Now I want to show you how to write to the same file. We will put a comment and say write to file. We will write to this file, so no need to redeclare it or put something else inside of it. We want this file, so we will use file name. The way we do that is using a buffered writer. Let me show you what it does. Buffered writer. Let's call it writer, and let's put null. Null means nothing, empty. We put null inside the writer for the time being. Let's see what's the error. A typo. Forgot an E. Yeah. That's how you write it. Buffered, no. Writer, we need a writer. Here it is. Buffered writer. Buffered writer. Okay, let's hover it and see what it does. Writes text to a character output string, buffering characters so as to provide for the efficient writing of single characters, arrays, and strings. Basically, you can use it to write to files using characters, arrays, strings. And that's what we will use it for. So let's create another string for our new text that we will put in the text file. And let's put something meaningful. I'm new text. So if this changes to I'm new text after we run this code, this means that yeah, we managed to write to file using Java. Now let's put something in the writer object. A new buffered writer. And inside the buffered writer, we will create another object, a file writer. And we should import it. It says to import it. We'll click Ctrl-Shift-O. Yeah, it imported the file writer and the buffered writer. And now we will need to give it an argument, the file we want to write to, which is this file name, file/foobar.txt. And it will also need to be surrounded by a try-catch. So let's click it, and now it's surrounded by a try-catch. Okay, so now we have a buffered writer that will write to our file name using the file writer that we passed to the buffered writer. Let's see what a file writer does. Constructs a file writer object given a file name. Basically, this is what is going to write our file. So we will use the buffered writer object and we will tell it to write. And we want it to write this. Now, after we declare a file IO object, sometimes the stream stays open, and there's no need for that. It's just a memory hog and we can close it. So after this runs, I want to close the file stream. For that, I will show you another syntax that is used by try-catch, that is part of the try-catch statement syntax. It's called finally. Finally. And that's how you declare it. So after try is successful, it will go into finally. That's it. So if the writer is not equals to null, meaning it's declared, we will use writer.close to close it, which will basically close it. And what? No. Really? Now? It wants me to surround it with a try catch again. Okay, let's do it. Let's just do it. And let's put the if inside and close this one, and what a mess. And this one was for the if. And yeah, let's put an end here that says end finally. So we know what it ends. You see? It ends the finally statement. And let's give it a tab. Very messy, but it does the job. So here we close the file stream. And these two lines are what's doing the writing. Let's test it. It will print blah blah because it got the earlier file content, and after that it wrote to the file again with a second call block. So here you see it did write to the file I'm new text. Let's run it again and you'll see it will say I'm not yet new text. Yeah. So it looks very long because of the try catch surrounding those very few lines. Here we use 2 lines to read and output the file, and here we use 2 more lines to write to the file and another one to close it. And because of all of those try catches, it looks very very messy, like spaghetti code. Yeah. What I do is I use a library I wrote that does these 2 operations, writes and reads files, not just a file. I will show you how to use it in later lessons, but I wanted you to be able to do this yourself from scratch, to read and to write to a file. Yeah, so let's run over it again. We get the file name, we put it in a new string object with files read all bytes, we give it the path with the file name, and then it's converted to a string because we put it in a string. And after that, to write to a file, we need a buffered writer, the content we want to put in the file that will overwrite the older content. Then we initialize the buffered writer with a file writer and give it a file name. We use write to write the new text, the new content, and then we close it, the file stream. And that's it for this lesson. You might need to look at it a few times to get it, but it's not very complex. It just looks messy with all the curly brackets and catches and tries and finallys and whatever. If you have a problem or questions, there's the Q&A. And that's it for this lesson.